The student book is the sixth one of a set of student books which altogether provides the complete set of information to master SDMX. Student Book 6 helps you to understand the XML technology. The different ways in which XML is used at Eurostat are presented here, and the different applications that have already been created are introduced. Detailed step-by-step exercises are provided, explaining the different specific aspects of SDMX and SDMX-compliant applications. This student book aims at providing an explanation about the XML technologies that can be applied in the use of SDMX. We will see one chapter explaining the basis of XML and schemas and namespaces, another chapter with the explanation of what XSLT is and real examples of conversions between SDMX files, and then an introduction of web services to give us a better understanding of how to apply them to SDMX standards. No specific prerequisite is needed to understand the content. Extensible Markup Language, XML, is a markup language used to describe the content and structure of data in a document. XML is an industry standard for delivering content on the Internet. Because it provides a facility to define new tags, XML is also extensible. Like HTML, XML uses tags to describe content. However, rather than focusing on the presentation of content, the tags in XML describe the meaning and hierarchical structure of data. The XML syntax uses matching start and end tags to mark up information. Information delimited by tags is called an element. Every XML document has a single root element, which is the top-level element that contains all the other elements. XML documents begin with a processing instruction. While it is not required, its presence explicitly identifies the document as an XML document and indicates the version of XML to which it was authored. Empty elements have a modified syntax. While most elements in a document are wrappers around some content, empty elements are simply markers where something occurs. The trailing slash in the modified syntax indicates to a program processing the XML document that the element is empty and no matching end tag should be sought. XML documents consist of markup and content. 6 kinds of markup can occur in an XML document: elements, entity references, comments, processing instructions, marked sections, and document type declaration. XML namespaces are used for providing uniquely named elements and attributes in order to avoid element name conflicts inside the XML file. This ensures reusability, in other words, the reuse of elements and attributes. It ensures modularity, or the use of elements and attributes from other standard results. And extensibility, that is to say, the incorporation of elements and attributes from other vocabularies. An XML namespace is a sequence of characters identified by a URI reference which are used in XML documents as element types and attribute names. In an XML document, the URI is associated with a prefix, and this prefix is used with each element to indicate to which namespace the element belongs to. A namespace is declared by using a family of reserved attributes. Such an attribute's name must either be XMLNS or contain XMLNS as a prefix. These attributes may be provided either explicitly or by default. An attribute's value is a URI reference, the string identifying the namespace. The namespace name has the characteristic of being unique. Here, an example of using XMLNS as an attribute name. We have the value for the name and the value for the attribute, and finally the namespace declaration. We can see another example using XMLNS as prefix for another attribute name. If this attribute name is XS, and with the following attribute's value, the namespace declaration should be as follows. A namespace declaration applies to all elements and attributes names, whose prefix matches the one specified in the declaration of the namespace. The following is an example of a DSD where the elements match the prefix structure declared. This DSD belongs to the demography domain. The prefix structure is defined here. We can see the different elements that are using the prefix: code list and name, for example. An XML schema defines the permitted building blocks of an XML document using the terms of a schema definition language, which is itself written in XML. SDMX makes use of the schema definition language known as XML schema, published as a W3C recommendation in May 2001. The benefits of using XSD schema are: XSD schema is an XML document. XSD schema supports inheritance, which means that one schema can inherit from another schema. XSD schema provides the ability to define new data types from the existing data type, and to specify data types for both elements and attributes. The root element of an XSD schema, already defined as an XML document, is schema. The XSD namespace declaration is provided inside the schema element. The namespace declaration defines the XML file as being an XSD schema. Element is the most important part of the schema. The kind of information that must be passed from the XML document is specified at this point. Element is limited by its type. For example, a simple type element can contain text only, whereas an element of complex type can contain child elements and attributes. The diagram provides an overview of the possible types of XML schema elements. One simple type can be atomic or non-atomic, if it is user-derived. And in the case of being built in, the possible values are primitive or derived. In the case of a complex type, it can be empty, simple content, or complex content. Only in the case of complex content, it can be a sequence, all, or choice. For example, inside one schema created to validate one SDMX data file, there are several specifications. In this case, there is the specification of the type postal code type, with one restriction. That means that if there is any element declared of this type, the value of the data file must be a string. In order to validate one XML file against a schema, the schema location attribute is used inside the root element of the XML file. This attribute consists, in nodes, of two components, namespace and schema. To reuse another schema, the first step is to include it. The include statement in the original schema must point to the secondary schema, and the target namespace should be the name as on the current working location. More than one schema can be included by adding several schema declaration inside the include statement. The recommended SDMX schemas are available through www.sdmx.org with a description of each one according to the SDMX file it has to validate. All SDMX ML document types will share a common envelope at the message level, as well as a set of common low-level components, so that header information and basic structure will always be the same. Here we can find the list of schemas used in SDMX standard, depending on the format of the message. Schema for describing all types of structural metadata, for datasets, for metadata sets, for related groups of metadata and data structures, and for all types of structural objects involved in registry-based exchanges. Generic data schema for data sharing exchange in generic format. Generic query schema for invoking web services. Key family-specific schema compact format. Key family-specific schema for utility format. Key family-specific schema for cross-sectional format. Generic schema for registry interfaces. Generic schema for reference metadata sets, and metadata structure definition specific schema for metadata sets. In addition to these different schemas, standard mappings and corresponding transformation tools have been developed to create key family schemas to transform XML data instances from one XML data description format to another, and from these formats into the corresponding SDMX ML messages. It is fact that all formats share a common information model that enables this approach to meet the wide set of SDMX requirements. Some SDMX ML schemas are the same for all key families and metadata structure definitions. These include SDMX message.xsd for generically describing the basic message structure common to all SDMX ML messages, SDMX structure.xsd for describing key families, metadata structure definitions, data flows, metadata flows, code lists, concepts, structure sets, processes, hierarchical code lists, and reporting taxonomies. SDMX generic data.xsd for describing data across key families for generic processing. SDMX query.xsd for marking up queries against SDMX conformat databases and web services. SDMX common.xsd describing the common constructs used in other schemas. SDMX generic metadata.xsd for generically reporting reference metadata, and SDMX registry.xsd for all interactions with the SDMX registry services. Note that for all key family specific and metadata structure definition specific schemas, the namespaces must be constructed following the rules for registry URN identifiers, with the addition of a single field at the end of the URN. For utility schemas, utility, header of SDMX utility data.xsd. For compact schemas, compact, header of SDMX compact data.xsd. For cross-sectional schemas, cross, header of SDMX cross-sectional data.xsd. For metadata report schemas, metadata report, header of metadata report.xsd. Here we can find some explanations of the meaning of each of the basic components of the SDMX files. For example, inside one compact file, where we can find the root compact data element, there are also other elements to be taken into consideration. There are 4 different namespaces declared which will be used inside the rest of the file. The basic one, the one corresponding to the domain of the data file and DSD, the one related to the compact format, and the one related to the schema instance. Once all the namespaces are described, to declare the schemas against which the compact file will be validated, the XSI schema location element is used. It is composed by nodes of 2 elements. The first node, the namespace and the schema location. The second node, the namespace here is a URN, and it is a unique namespace declaration for this file. And finally, the last node, with the declaration of the namespace for compact format and the relative path to the schema. This is another example of a compact schema created from a previous DSD, used to validate any SDMX data file in compact format. Here we can see the main elements of the root element. There are 5 namespaces specified in this case. The basic namespace for all the schemas, the namespace common, which is relative to any SDMX schema, the use of compact namespace because it is a compact schema, the basic namespace, and finally, the one used in the data file when the location of the schema used for validation is declared. Since one SDMX schema is also an XML file, to validate it, out of the root element, different imports sentences are declared to get the reference to all the schemas needed. This also means there are 3 schemas this XML file is going to be validated against. Furthermore, in this schema there are other specifications. The target namespace is the namespace of the data file and is needed at the time of validation. This means that this target namespace must be the same than the one declared for the data file. In this example, the following declaration according to the target namespace should be declared in the data file. And finally, the attributes element form default and attribute form default that should always have the same values as we see here. These 2 values are used to indicate whether or not locally declared elements and attributes must be unqualified. XSLT is an XML-based language used for the transformation of XML documents into other XML or human-readable documents, for example HTML. The idea is that the original document is not changed, but a new one is created using one XSLT document based on the content of the original document. In this example, we can see a conditional sentence which depends on the element code list. The main element is the conditional element. This means that if the expression to be evaluated, test, does not have an attribute code list, the output value will be extracted from the attribute concept ref and with the literal text type. In this exercise, we are going to explain how to transform an SDMXML structure file to an HTML presentation using an XSLT file. The first step is to open one structure XML file. Go to the File menu and then click Open and select the structure XML we are going to work with. We have our structure file loaded, and we have to select the transform action for this file, using the XSL file to make this action. So we go to the XML menu option and click in XSL transform. Then we select the XSL file we are going to work with. A new file is generated by the XML copy editor tool with HTML code. We save this new document as an HTML page. Once it is saved, we can open this new HTML file in any HTML browser to see the results. We can access the information of the SDMXML structure file in a user-friendly format. In this exercise, we are going to see how to create an XML schema from an SDMXML structure file, and having the XML data file, how we can validate this data file against the schema we created according to the previous SDMXML structure file. The first step consists in opening a structure XML file. We go to the File menu and press Open. Here we select the structure XML we are going to work with. Once we have our structure file loaded, we select the action Transform for this file, selecting the transformation file we need for this action. So we go to the XML menu and press in XSL Transform. Here we select the transformation file needed. A new file is generated by the application with an XML code. We save this new document as a schema file. We can use the schema created to validate XML data files. For this purpose, we open our XML data file. We go to the File menu and press Open. We select the XML data file we are going to work with. As we can see in the XML data file, there are some namespaces we have to take into consideration. XMLNS stat_sts is the namespace that has to be declared in the schema created before specifying in terms of validation the namespace used in the data file. To do this, in the schema we have to add the namespace as follows. In the XML data file, according to the XSI schema location attribute, there are two schemas the XML data file is validated against. schema_to_validate.xsd should be changed to the schema we created before, the one we created to tell the parser we want to validate the XML data file against our schema. If we check the namespace that is used in the XML data file for this schema, we can see that there is a URN path that must also be declared in the schema created already as target namespace inside the element XS schema to maintain the references. Now we can validate the data file. In this example, we are going to create an HTML file from an SDMX data file. The first thing we have to do is open Compact Data XML file. We go to the File menu and press Open, where we select the Compact Data XML we are going to work with. For the process, we have to change two values of the transformation file before using it. We add the values of the data file and the DSD inside the file. Input_file is the data file we are going to process, and lookup_file is the schema we require. In this case, estat_eurostat_sts_compact.xsd. At the beginning of the document, we should have these two lines with no data elements. It is important to have these two files, data file and DSD, in the same folder as the transformation file, since we are using relative paths to find the documents. Otherwise, we have to put the absolute path where the documents are stored. Since we had our data file previously loaded in the XML editor, we select the action Transform for this file, selecting the transformation file we changed before. We go to the XML menu and select XSL Transform, where we select the transformation file we are going to work with. A new file is generated by the XML copy editor tool with an HTML code. A new HTML page has been created. We save this new document as an HTML page, and we can open this new HTML file in any HTML browser to see the results. We have a user-friendly result of an SDMX data file. Web services represent the coming generation of Internet technologies. They enable computer applications to exchange data directly over the Internet, essentially allowing modular or distributed computing in a more flexible fashion than ever before. Many web services standards already exist, and there is no need to reinvent them for specific use within the statistical community. Specifically, Simple Object Access Protocol, or SOAP, and WSDL, Web Services Description Language, can be used by SDMX to complement the data and metadata exchange formats they are standardizing. Since it becomes important to be able to describe the communications in a structured way, WSDL addresses this need by defining an XML grammar for describing network services as collections of communication endpoints capable of exchanging messages. It is important to observe that WSDL does not introduce a new type definition language. WSDL recognizes the need for rich type systems for describing message formats and supports the XML schemas specification as its canonical type system. Here we can observe an example of Census Hub WSDL file. All SDMX web services should be described using WSDL instances according to the use of WSDL to specify the aspects of this multiple message exchange which they support. To ensure interoperability between SDMX web services, compliance with sections of the WSI Profile 1.1 is recommended for all SDMX web services. In this section, some examples of SOAP envelopes used in SDMX registry are going to be explained. Two parts can be identified clearly in any SOAP envelope, which is the root element of the document, the SOAP header and the SOAP body. The SOAP header includes a custom element named security header used for conveying authentication information in the form of 3 strings. For example, a username, a password, and a domain. Due to the fact that this information is too sensitive to be sent, it is strongly recommended to enable HTTPS in the server where the web service is. The most important part of this SOAP envelope is presumably the SOAP body, which, due to the fact that the web service is a document-style implementation, must include a registry interface SDMX ML message. In the example, the query is not shown. Although the web service would respond with a registry interface SDMX ML message on the occasion of an incoming request, there is a chance that something goes wrong before the actual registry interface message response is prepared. For example, connection to the database is not feasible. In such cases, the web service responds with a SOAP fault message. One SOAP request according a WSDL structure may look like this. And the SOAP response example according to the same WSDL structure should look as follows.